our goal is to calculate the integral of 2x squared minus x plus 4 divided by x cubed plus 4x dx using the method of partial fractions. In the method of partial fractions, we try our best to factor out the denominator. So first, factor the denominator. Your denominator is x cubed plus 4x, that can be written as x times x squared plus 4. This guy cannot be factored more. Now, based on the denominator, we decide on the partial fractions. So your denominator is x times x squared plus 4. So the partial fractions that you end up with is a divided by x plus, now for your second fraction, x squared plus 4 goes on the denominator. On the numerator, you end up with a linear expression like bx plus c. Then your goal, your job is to figure out what a, b, and c are, and then take the integral. So let us try our best to find a, b, and c. I'm going to write this on the left-hand side. So I have 2x squared minus x plus 4 divided by x cubed plus 4x. That needs to be written as a divided by x plus bx plus c divided by x squared plus 4. Let me move this a little bit here to avoid any confusion. So you keep your left-hand side. Your left-hand side is what you see here, 2x squared minus x plus 4. Your denominator is also x cubed plus 4x. Now on the right-hand side, take common denominator. You're basically moving backward, all right? In this process, when you're moving backward, you are building a new fraction, and that fraction on the right-hand side must be equal to the fraction on the left-hand side. So this guy is equal to. So when you're taking common denominator, this is a times x squared plus 4 plus, now you have bx plus c times x. The denominator is the same as what you see on the left-hand side. There is no difference. X squared plus 4 times x. This guy on the left-hand side is equal to the right-hand side. The denominators, we don't have any issue with the denominators. The only issue is with the numerators. Numerators on the left-hand side and right-hand side must be equal to each other because you have equality between fractions. Well, okay, how can I solve this? This is a times x squared plus 4 plus bx plus c times x. What I'm going to do, I'm going to distribute a into parentheses. I'm going to distribute x into parentheses. So I end up with a times x squared plus a times 4 plus, now if I distribute x, I get bx times x, which is bx squared. So you have bx squared plus c times x And on the left-hand side, you have this quadratic expression, 2x squared minus x plus 4. So quadratic expressions on the left-hand side and right-hand side must be equal to each other, right? So you can conclude that 2x squared is the same as ax squared or a plus bx squared if you want to simplify this further. And at the same time, what you see, you have linear expression on the left must be equal to the linear expression on the right. What's the meaning of that? It means that minus x must be equal to cx. Okay. What else? What is another observation that we have? Also, we have 4 as a constant equals to 4a. These two must be equal on both sides. So 4 and 4a must be equal to each other. But 4 equals to 4a, give me an answer for my a. If 4 is equal to 4a, from this equation, a is equal to 1. I found a. I can take a look at my first equation. From first equation, 2x squared is equal to a plus bx squared. I don't have any issue with x squared and x squared. It says 2 is equal to a plus b, but we know that a is equal to 1. Just substitute that here. So you get 2 equals to 1 plus b, or b is equal to 1. Well, I found my a and b. What is my c? Well, from the second equation, since negative x is equal to cx, c is negative 1. Perfect. I found all the missing pieces. I need to go back to this equation, substitute everything, and then take the integral. Okay, let us do that. I have a over x plus bx plus c divided by x squared plus 4. Now I'm going to take the integral with respect to x, but what is my a? My a is equal to 1, so I'm just going to substitute that over here. Why not? My b is equal to 1, so my b is 1. What is my c? My c is negative 1. So here we go. We get 1x minus 1. When you're taking the integral of these fractions, it's much more easier to deal with them. Perfect. So let us continue. This integral can be written as the integral of 1 over x dx plus integral of x minus 1 divided by x squared plus 4 dx, which in turns can be written as integral of 1 over x dx plus the integral of x divided by x squared plus 4 dx minus the integral of dx over x squared plus 4. I broke this guy down into the summation of two fractions, which are here and here. Now, remember that if you have the integral of du divided by u, it is ln of absolute value of u plus c. This is from calculus. Integral of du divided by u is ln of absolute value of u plus constant of integration. Try to keep everything nicely, but just slip away. Okay, perfect. So my very first integral becomes ln of absolute value of x. For the second integral, you can use u sub. U is x squared plus 4. Du is 2x dx. So I'm going to multiply and divide by 2. This becomes a half integral of du divided by u minus what? Minus the integral of dx divided by x squared plus 4. What is that integral? That integral, as you remember, is a half inverse tangent of x divided by 2. So let us continue. We get ln of absolute value of x plus a half ln of absolute value of u, but u is x squared plus 4 minus a half inverse tangent of x divided by 2 plus constant of integration. So again, the integral of the x divided by x squared plus 1 is inverse tangent of x plus c. But when you have x squared plus a number like a squared, the integral of dx divided by x squared plus a squared becomes 1 over a inverse tangent of x over a plus constant of integration. So that's how we use partial fractions, u sub, and other techniques that we learned in calculus to calculate these types of integrals. Here we go.